Engineers are ingenious professionals. Engineers invent, design, verify, and qualify. Engineers are the professionals who make our lives and businesses prosperous and safe. The Florida Engineering Society is proud to put our engineering professionals in the spotlight so that they may educate, share information, and introduce you to the world of engineering that is thriving in Florida. Here's your host of the Engineering Florida podcast, Sam Yates, with today's guest. Hello, everyone, and welcome to another episode of the Florida Engineering Society Engineering Florida podcast. It's a mouthful, but it is very important that we talk about the various things that are happening within the Florida engineering circles. And today, we may not be on the road again, but we are on the road topic again. Pardon me, Willie Nelson. What better way to go over the topics that are related to transportation services than to speak with an engineer who is top of the field, knows transportation like the back of his hand. And my guest today is the Senior Project Manager for Dewberry. Now, Dewberry is a nationwide firm with planning, design, construction. As I mentioned, they operate all over the country. They've been around for more than a half century. And Mr. Evans, welcome to the program today.
Thank you, Sam. I'm honored to be here.
Now, I have to say that when I made the introduction and was introducing you, I didn't want to in any way infer that you've been there for 50 years, but that company's been around. You have quite an impressive bio, and I want to get into a lot of your areas of expertise. But before I do that, tell us a bit about yourself first.
Sure, Sam. As you mentioned, I'm a senior project manager and have been working in the transportation planning and design field for about 18 years now, a little over 18 years. I grew up in a few different areas around the country, St. Louis, Missouri, New Jersey, Columbus, and Cleveland, Ohio. But I've lived in Orlando now for about the past 30 years since coming here to go to UCF. I started at UCF as a mechanical engineering major, and while I was there, I worked at a co-op while in school, and I moonlighted a bit as a pizza delivery driver at the time to make some extra money. The franchisee of that pizza company liked how I was working and making deliveries efficient, not just for me, but for the whole driver staff. And he offered me a management position, and it paid very handsomely, more than I probably could have made as a graduate engineer out of school at the time. So I left school and I did that for about 7 years. I was managing restaurants around Orlando and doing really well money-wise. But after 7 years, it was really kind of heavy on the hours. I was working lots of long hours, not a whole lot of days off. I'm doing well financially, but I'd gotten married and I wanted to start a family, and that just wasn't going to work well with raising a family. So I decided to go back to school. And at the time, I also decided to switch to civil engineering and get into transportation design. Once I graduated, I started working with a firm here in Orlando, and I really never looked back. I couldn't be happier with my choice. As I said, I'm a project manager. I'm working with as the deputy program manager of the general engineering consultant to the Central Florida Expressway Authority is my main task at this point. I'm managing major projects for them and other aspects of their $4 billion 5-year work plan. And I have a son in college at UCF. He's studying engineering, and another one still in high school. And I'm really enjoying my career as an engineer.
All right, I'm going to ask a question, and for those who are not in the pizza industry, they may not get the question, but you have spent a number of years in the pizza industry. Did you dock the dough?
Dock the dough by using the rollers with the spikes on it? Yes. Not at first, but that became a company policy after about 5 years, and I really I was kind of hesitant when they did it, and I thought it degraded from the quality a little bit, to be honest.
Now, the reason I asked that question, when you were talking about being in Ohio, I also spent a good number of years in Ohio, the Dayton, Cincinnati, Columbus area as a television reporter, anchor, investigative reporter. But I also did public relations, and one of my clients was in the pizza industry, Casano's Pizza.
I remember
And
Casanos, yes.
yeah, awesome pizza. And that was one of the first things that if you're going to represent a client, you always have to do a bit of what the client is doing. And I made pizzas. And
Hmm.
the most intriguing thing was, Sam, do you know how to dock the dough? And I was like, no, I do not. So I'm glad that we share an experience there. That's a lot of people don't get that. And for those of you who are going, okay, move on, move on. It's an experience. It definitely is. Now, with your background, you are all over the world of transportation. So, of the many aspects, whether it be streetcars, turnpike, fast bus transportation, your favorite, if you had to pick out a particular area.
Uh, well, I got in this field to really do highway design, and that is by far my favorite mode and aspect of the profession. I do like all the other modes too, and I think that having the understandings of the challenges of those other modes helps me be a better engineer. Um, but it really kind of stems from, when I was growing up, when I was 5, my father would take us out for drives around town and around the countryside outside of town. And as most little kids would do, as they, driving around before they had portable video games and smartphones and other things to keep them occupied, they'd fall asleep in the car. And I'd fall asleep, and I'd wake up, half hour later and not know anything about where we were. So I would ask, "Hey, Dad, where are we?" And my dad, being a little bit of a tease, would say, "Oh, we're lost." And I would just get scared and cry, and I would lose it. So my dad would pull over into a parking lot, and he brought out the map, the road map of the area, and he would show me, look at the street sign, look at the map, match that up, and this is where we are. This is what the road looks like. You see that curve there? That's the curve on the map. Taught me how to read a map, and from that point, I was hooked, and I would absorb every map I could get my hands on. I really loved the Rand McNally Road Atlas. And by the time I was 10, I had memorized the entire interstate highway system, even though I had never driven a car at that point. But I really liked roads, especially highways, and that is by far my favorite aspect of transportation design.
I do have to say that I miss maps. I mean, GPS is okay, but there is just something very ethereal about pulling over, looking at a map, and just it's the identification process. So I'm right there with you. Our kids today need to know a little bit more about maps and plotting, but as you have had that experience in the highway industry, highways in particular, I know that having been there and been to various public hearings, there is the public hearing. There's an approval process. There are different municipalities, government agencies. You have to work with all of them through a process. And probably, if I had to guess, one of the stickiest points of that entire process is the public. So when it comes to the public and they're wanting to get the pitchforks out because not in my backyard or whatever they might be wanting, how do you deal with a public that sometimes does not have the best attitude from your experience?
Well, here's where I get to draw a little bit from my experience in the restaurant business. The best ways to deal with an angry customer are much the same as dealing with an angry member of the public or an angry politician. There really is 2 rules you need to follow. First is you can't be defensive. I know it's your project, your design, you've poured hours and hours and years into it, but you can't be defensive about it. You have to understand there's a different perspective out there, and that's okay. And then the second is you just have to be open-minded and listen. People just want to be heard. They want their concerns not only understood, but relayed back to them in a way that helps them understand that you understand that project, that their concern. And we hold public meetings and receive public comment mostly to inform people about the project, but also to solicit comments and ideas. And as engineers, we tend to delude ourselves at times that we know what's best. But that's a delusion. Sometimes that's true. But I kid. It's not always true. But there's always learning opportunities from every public meeting I've come across. I've yet to have one, even one where I only had one person show up. I still learned something from the public in that public meeting, and it really helps us make that connection, and especially to the community. For example, I was working on a project in St. Cloud, Florida, where we're widening an already busy highway. And there was a gentleman there who was absolutely apoplectic about this roadway widening, and it was getting closer to his mom's house. And he was screaming at the staff at the meeting, and just absolutely tearing into them. And so I went over to him, and I just started asking him a few questions, not really trying to talk to him about the project, ask him questions about him and himself, and trying to understand his viewpoint a little better. And it turned out we had a connection. He worked with a good friend of mine. So once I was able to kind of establish that rapport with him and calm him down and get him to talk a little bit more civilly, we were able to really kind of get a good dialogue between us on the finer details of the project. And in the end, he became actually an advocate for the project. And he invited us to his community meeting to speak about the project, and we got his community's buy-in on the project, and it moved forward, and it turned out great at the end. Now, that's not going to happen with every project and every irate citizen, but being able to get to that point, even on someone who is not going to have their mind changed, at least you can have them help understand that they're heard and that their concerns are valid, and that we're not just dismissing them. And the project may or may not be something that they like, but we can at least try to get that input and seek that connection with the community.
And I think that communication process is vital. When it even comes to working with your client or whomever the project might be, sometimes there's a different point of view there, consultant versus client's view, and that one can be critical. How do you work around those?
Well, I think it's good. I've had roles where I've been on the consultant side, and now I'm on a role where I'm really kind of more of the owner's rep client side. I'm not exactly the client, but I have to take on that viewpoint. In that aspect, it is differing from this perspective of, the client wants to see the project and they want to see it move, and they want to understand what the challenges are, and they want to understand how those solutions to those challenges get developed. On the consultant side, the consultant just wants the project done quickly, moved and built, and we just want to move ahead. And there's two ends. There's two ways to get to the same answer there, but the reality is the more we can try to understand both sides of that coin, the better off we as engineers can operate on either side of the house. It's not all clients are out hell bent for profit, but or not all consultants are hell bent for profit. Some consultants are, but that's okay. That's what we're in business to do. We are in business to make money, and the clients are in business to service the public. So we can find that happy marriage between those two ideas. It's just you have to sometimes look at it from a different perspective.
I find that in every podcast that I'm doing with a member of the Florida Engineering Society, that engineers are, in many, many cases, problem solvers of one sort or another. And what you're describing there is part of that. I know it. I've seen it. Engineering is a wonderful industry because you have a built-in problem solver mentality to begin with. When it comes to solving those problems, quality assurance, quality control, they sound like two things that could be diametrically opposed. Which is important, and which should you strive to do?
Well, they're both important, Sam. They're absolutely both important. And yes, you're right. They sound like they should be the same thing, and they're just not. They're both important steps to a successful design project. And from an engineer standpoint, you really can't skimp on either one. Where, quality assurance is essentially looking at the project holistically and making sure that every aspect of that design is incorporate, everything that should be included in that design is incorporated, that everything that should be part of that submittal is there. And then you've got quality control to make sure that all the T's are crossed, all the I's are dotted, all the math is correct, etc. And a lot of times I think we lean more on the QC side as engineers than the QA side. And we end up, sometimes there's projects that get submitted, everything looks great, from a technical perspective, all your cross sections look great, all your details are great, except the sheets are out of order. So you kind of miss that step. Or things that we made all this decision to design this project and to phase our traffic control in a certain way to build it, and the drainage trunk line got designed on the wrong side of the road. So it was actually built in phase 3 instead of phase 1. So the design didn't get, you couldn't build the drainage design correctly. And those things eventually get caught, but when they get caught by the contractor, it's expensive, both for the client as well as the firm. And it's those sorts of issues that make it equally important, if not more so important, to kind of lean on the QA side than on the QC side. But they're both heavily vital to a correct and precise design.
Ladies and gentlemen, when I speak with guests or we communicate with guests, I always look for a golden nugget. And in writing the introduction, the music introduction for this particular program, I came across the phrase that engineers design and innovate, and innovation is a passion for some. And it's interesting. When I was looking for a good definition, that was one of the first definitions for engineering that jumped off the pages of the book to me. And it was like, yeah, that's exactly what they are doing. But you had a different way of talking about something that I wish I had thought of.
It's something I've seen, again, and this is coming from my role as a engineering consultant, and I'm managing a program for a client. So I get to see a lot of different design firms' approaches. And I see a lot of times where consultants, design engineers will get stuck on, the standards, and the standards are great, but are the standards beating the ingenuity out of us as engineers?
Right.
And what I mean by that, let me start off by saying the standards we have in Florida, and I've worked in a couple of different states, the standards we have in Florida are great. They are fantastic. They're a great tool and a great reference to help streamline a lot of the roadway design process. Where we run into problems are where the standards don't quite fit a particular aspect of a project. And in my role, I just see too many engineers that get stuck by that. They either ask the client or me how to design the solution, or just say we can't do it, and point to the standards, since standard says this and we have to do this and that, and it doesn't work like that. And so if there's sometimes asking for direction from a client is a valid opportunity, especially if there's certain ways a client wants things done or how things want them to look. But it seems like that opportunity where the standards don't quite fit is an opportunity for that engineer to shine and come up with an opportunity for them that a lot of engineers just seem to be missing. I'm not saying everybody. I'm just, it's here or there, but seems to be a little bit of a trend to me. I don't think there's any shame at all in asking for help, whether that's within your company, to a partner consultant, to the client itself. But sometimes, that seems like some of the attitude is, if the standard doesn't work, then we can't finish the design, and that's what frustrates me. So I love it best, and I see this a lot too, where the engineers see an issue and come up with a solution, or multiple solutions, even better, and recommend a solution that fits the best, and then asks, is this okay? And that's where I'm I'm really excited because that's where I see the ingenuity coming in. And sometimes it means maybe we draw from this other standard that kind of sort of fits the mold, and sometimes it's a brand new design. And those are the opportunities that I think that really allow us to express our creativity and our ingenuity. And I just don't want us to be beaten down by the standards to the point where we can't do that.
That for anyone in any career, when you get to the point of it becomes rote and you're just doing it because let's get up, go to work, come home, go to bed routine, you're probably wasting a lot of your time. So that innovation is a critical factor, and I have to stress that. So I totally agree with you on it. One thing that, well, we have a number of things in common, but you and I both have a commonality in communications, whether it be verbal or whether it is in writing. The way you communicate can have a tremendous impact. I spent years learning to write as people talk versus the textbook style Associated Press textbook of this is a sentence, this is a verb, this is a transition. People don't talk that way. So when, in my particular profession, it took a lot to unlearn the school lessons to write as people communicate. But writing is critical. How you write is extremely critical when it comes to engineers.
Absolutely, Sam. Absolutely. The ability to write well as an engineer, a lot of us, we'll say, well, we did great on the SAT math, but not so great on the verbal. But that's not really an excuse for us, because I actually spend way more time writing reports and emails and memos and helping to do quality control on messaging to the public and setting up scripts for presentations than I do actual math, actual calculator calculations. And it's the ability to take that idea, put it on paper, or put it into a viable memo or report that can be understood by a wide range of people. And it's really easy to, especially in our profession, to get bogged down into the dry language of this curve is this degrees and this angle and this radius, and it's hard to break out that into something that the public's going to digest. But there's ways that you can expand your writing into something that can be used, like say in an executive summary or a summary position, that helps bring that technical knowledge into a wider range of understanding by the public, by clients, by other engineers, et cetera. So you kind of have to write with the audience in mind, for Absolutely. One. And whether that's a report that's going to get reviewed by the client or Federal Highway or Federal Rail or whatever, or is that going to be something that you're going to eventually have to present to the public? And you kind of have to keep I like to write with that in mind, so that when I'm explaining something, I kind of try to explain it in a way that makes sense to the most amount of people. I'm trying to use common words and phrases that help understand the topic. So, use of analogies is great, but you don't want to get too bogged down into that. You definitely want to try to write in a voice, and not just everything wrote, as you mentioned, everything AP style, where it's just the facts, ma'am, kind of Joe Friday stuff. You definitely want to add some personality to it, but you don't want to go overboard with that either, because then you kind of lose the professionalism of that particular report or memo.
It is an art. Now, before I go much further into the program, I want to know, can you come back for another episode? I'm having a great conversation, but I know the clock on the wall is going to count me down here. Can you come back again for another episode?
Absolutely. I'd love to.
Before I forget it, though, let's talk about that surface transportation that is so important, that was really the baseline for where you are today. You've had experience in rapid transit. I mentioned streetcar corridors, transit station, people movers. We're seeing a push for autonomous passenger vehicles over the Lakeland area. There's actually, I believe, a test track where a lot of the things are being tested before they're put out onto the turnpike. And actually, I think we have autonomous vehicles with a backup driver, semis on the turnpike being tested now. But there's also a big push for electric, as we all know, electric vehicles. Autonomous electric vehicles are coming. There's also vertiport. And I mentioned that because back in our stomping grounds in Ohio, Dayton, Ohio, Joby Aviation is going to be producing 350 electric taxis, air taxis. And that too is going to require charging stations. Your vantage point, can we get to that point to support everything charging station wise, or how do we do that?
That's an excellent question, Sam. And we've been looking at that problem. I mean, people have been looking at that problem for over a decade already, even when we started really kind of looking at the whole electric vehicle aspect to transportation. From what I understand, and part of my job with CFX is we're working with a group called Aspire, which is a university consortium that's funded by the National Science Foundation, based out of Utah State University, where we are looking at providing electric induction pavement charging at highway speed. So it's a really exciting concept. It's essentially like the little pad that your phone light rests on to charge up your phone wirelessly, but for a car moving at highway speed or a truck moving at highway speed. So we're actually going to be doing a pilot project on a new expressway out in Lake County, where we're going to be putting in a segment of pavement that will allow for this wireless charging at highway speeds. And it's an exciting technology, but it also allows us to realize some of the limitations of the system overall. Electrification for the whole country, our electric grid is just simply not up to the task as it stands today. Something to the around it. Once the vehicle fleet, if we kept the same sort of charging apparatus that we have today and just expanded more charging stations, more electric buses, et cetera, once we get to about 40%, maybe 50% of the vehicle fleet on the road being electric vehicles, the grid cannot support that much. And that's only half at best. Wow. So we need more support from the grid infrastructure, more electrical generation, more electrical transmission, to be able to have this all electric dream. And from that perspective, no, we're not ready for it. But we understand what those challenges are and how we get to from where we are today to that future point is going to be the critical path of how we really develop that next generation of vehicle propulsion.
Please keep me posted on that highway test with the built-in charging system. One of my partners in the 5G industry with cell towers had been experimenting with that with Tesla a number of years ago, and it was just so fascinating. So I'm glad to see that is actually getting out into the field. It's that innovation. Back to that word again that we were talking about earlier.
There are some stationary wireless charging out there already. There's a couple of companies that sell it to electric bus fleets. There's a couple of companies that are looking to install it for people in parking lots you drive your car over, it charges while you're in the store or whatever. But this is really kind of the first pilot in the United States that would use it at highway speeds.
With rail, and I know highways are your forte, but with rail, here on the east coast of Florida, where I'm located, we now are seeing 32 trains a day from Brightline, Miami to Orlando, 500 yards from my office, and I can tell you mornings are very busy, afternoons are very busy. It's almost that hub approach to air traffic, but it's in the rail corridor. Big difference in constructing highways per mile of construction cost versus rail. Is Brightline, in your opinion, based on cost and everything else that's happening, a good model?
I think Brightline is a good model because they were part of their corridor. They took over the existing Florida East Coast Railway line and repurposed that and made some adjustments to that design to allow for higher speeds and higher speed trains. But it wasn't really that full speed European, Asian maglev train kind of thing.
Right.
But then they have the new corridor between the airport, and it runs along 528 out to Cocoa, where they built a sealed corridor where every crossing is a grade separated crossing, and they have fencing on both sides so you don't have animals or pedestrians potentially crossing into it. And they can achieve that higher speed, 120, 130 mile an hour running speed, which would be absolutely great to run a high speed train, but for intercity passenger rail. I think that's the good model, and that's really closer to what the European or Asian models are for running that high-speed rail. But that does come with a rather significant price tag, especially with how our development has occurred in this country from years ago until now. So, building a new sealed corridor is pretty much only achievable kind of like what Brightline did along an interstate highway, where you already have kind of a sealed corridor and you just kind of have to enhance that to build additional bridges and so forth. So I do think that aspect of Brightline is the model for the future of high-speed rail in this country.
Excellent observation. We've covered a lot of territory, and I just want to make sure, are there any other items that you would like to touch on before we wrap the program up today?
Not today, but I'll be happy to come on and talk about things at a future podcast. This has been a great conversation.
And ladies and gentlemen, I'm going to hold him to that because, for our audio listeners, you can't see the expressions, and as you were saying that, the smile was beginning to spread. And it's like, I know you have more that we can talk about, so rest assured that we are going to have you back. And I want to thank you very much, Carnot Evans. You are the chair of the Florida Professional Engineers in Industry segment. Did I get that right?
That's correct, yes.
And that is important because it says that you are leading edge of the industry. And a lot of people, hopefully, as we do more of these programs, will begin to understand that there's not a cookie cutter mold for engineering. Engineers do a lot of things, and they make life better for us.
You flatter me, Sam. Thank you.
All right. I'm going to look forward to that. And that's going to wrap up this edition of the Florida Engineering Society podcast, Engineering Florida. I'm your host, Sam Yates, and until our next episode, have a great day, everybody. Thanks for listening to another informative episode of the Engineering Florida podcast. Our goal is to help educate and inform everyone who listens to our podcast about our members and topics of interest to the Florida Engineering Society. On behalf of the Florida Engineering Society and the Engineering Florida podcast, have a great day, everybody.